Okay, this is Mr. Sitta. I'm working on Chapter 11 review. This is to get you ready for a test. The test will be in a similar format. It'll be multiple choice. Okay. In a double replacement reaction, hydrogen chloride and sodium hydroxide, so HCl plus NaOH. Now it's funny they called this hydrogen chloride because you could call it hydrochloric acid. In its pure form, it's hydrogen chloride. It's a molecular compound. Only in water does it separate as an acid. But this would be a double replacement. I would look for the H to go with the OH, and that would produce water. So an acid plus a base always neutralize each other to make water. Now what's left is the Na goes with the Cl, so you get NaCl, and that's an ionic compound, which is a salt. So acids plus bases always make water plus salts. So another product is water, and not potassium chloride, but sodium chloride. Okay, when potassium hydroxide, now I'm not going to look at any of these. I'm going to go ahead and just balance this open-ended. So if I have KOH, that's plus 1 minus 1, plus barium chloride plus 2 minus 1, so it's going to be 1 to 2, plus BaCl2, okay, they're going to produce KCl. Now that's in a 1-to-1 ratio because it's plus 1 minus 1. This 2 does not transpose to that at all. And then the barium will go with the hydroxide. And that ratio is plus 2 minus 1, so it's always going to be BOH2. All right. To balance it, I have 2 hydroxides, so I want to put a 2 in front of there. That gives me 2 Ks, so I'll put a 2 in front of there, and that balances the 2 Cls. Okay, so now that I've balanced it open-ended, it goes with D. You want to avoid just trying to looking at these and guessing. You actually want to just balance it open-ended. I'll do the same thing here. I want to balance the equation when aluminum reacts with copper 2 sulfate. So copper 2 sulfate is plus 2 minus 2, aluminum 0. So I have Al0 plus CuSO4. All right, I recognize that this is a single replacement. It's also going to be a redox. The aluminum is going to oxidize. So the aluminum is going to replace the copper. A metal will replace the other metal. You end up with aluminum sulfate plus copper getting kicked out. Now the copper is 0, so it's just copper metal coming out. Now I have to balance. This is the one thing that you must do. You have to balance the formula for aluminum sulfate. It's a plus 3 and a negative 2 charge. So you get a 2 under the aluminum and a 3 under the sulfate. And that's what you use the charges for. Now I'm going to get rid of them because you don't want them showing up in the equation. And now that's where I start at this 2 to 3 ratio. 3 sulfates, so I'm going to put a 3 in front of sulfate. And then you always do any element by itself last. There's 2 for aluminum, so you end up with 2 in front of aluminum. There's 3 next to copper, so you end up with 3 individual coppers. You would not put it as a subscript. You would not put it as a subscript. It's coefficient. Okay, and there's your balanced equation. So that matches up with C. My answer. Okay. What is the balanced equation for the reaction that takes place between bromine and sodium iodide? There's bromine by itself, which is a 0. Well, here you have to remember that bromine is a diatomic gas. So it's Br2, it has no charge. Sodium iodide, plus 1 minus 1, is NaI. On the other side of the equation, this is also a single replacement, and it's also a redox. Well, bromine is not going to replace sodium. Bromine's a non-metal, so it's going to replace iodine. So it ends up being sodium with bromide. Bromine on the left, bromide here, and it's reduced. It's actually got a -1 charge. Sodium's got a +1. The 2 does not show up here. This is not a diatomic element. This is a compound. Diatomic molecules are only by themselves. Okay. The iodine gets kicked out. Now its charge went from a -1 down to a 0, and it's also diatomic if you remember Hankelbrief. There's two things in Hankelbrief here, bromine and iodine. By themselves, they have to be written with a 2 underneath them. 2 and 2. Now you end up with 2 iodides, so you got to have a 2 for a coefficient for NaI. Having 2 NAs would make you put a 2 here, but also the fact that you have 2 under the bromine makes that all balance. So there's your balanced equation. Br2 plus 2 NaI goes to 2 NaBr plus I. The secret to doing these correctly is not to try and guess them. Balance the equation open-ended, and that's how you'll get it right. Okay. What are the correct formulas and coefficients for the product of this double replacement reaction? Well, this reaction is a base plus an acid. I know it's an acid because it has H in front of it. I know a base because it has OH in front of it. It's a double replacement. This is a double replacement and a neutralization. The H is going to go with the OH. And so that makes water, H2O. Okay. The other product is the salt, rubidium plus phosphate, PO4. So, in rubidium phosphate, you have a -3 phosphate, a +1 for rubidium, so it's crisscross, a 3:1 ratio, Rb3PO4. If you look at an acid and a base, I can look at this as hydroxide plus 3 H's. So I would need 3 of these. And you need also 3 because of the 3 on the rubidium. And that produces, if you look at water as HOH, it would produce 3 of them. You have, if I just count my hydrogens, 3 hydrogens, so I need a 3 in front of that. Now, you end up with 6 waters. 6 hydrogens. 3 of the hydrogens came here from the hydroxide, 3 came from the acid, and that's a balanced equation. So the left side would be, the products is what we want. And what we want is 3 waters plus Rb3 PO4. Okay. All right. Which is a product of the following combination reaction? Okay. If I looked at this in words, aluminum plus iodine make, okay, this is a synthesis. Okay. Well, what it makes is they come together to make aluminum iodide. Now, iodine has no charge. Iodide has a -1 charge. Aluminum has a +3 charge, so your aluminum iodide has a ratio of 1:3, crisscrossing. And so your final reaction is aluminum 0 plus iodine, which is diatomic, I2, makes Al I3. Now I picked this reaction because there's a 2 here. This 3 has nothing to do with this being diatomic. The 3 comes from your ratio of aluminum reacting with iodine. Aluminum turns into a cation with the +3 charge. Iodine's a -1, so it's always in a 1:3 ratio. And if I went ahead to balance it, having 2 here and 3 there, my lowest coefficient, my lowest common denominator would be 6. So I would need 2 of these. 2 times 3 makes 6. And 3 iodines. 3 times 2 makes 6. And that makes you have 2 aluminums. And they want the product, and the product would be ALI3, which is C. They didn't make you balance it, but I just wanted to show you the balancing involved there. In a synthesis, a special reaction, if I have a metal and I combine it with oxygen, they would come together to make a metal oxide. Okay, so C, metal oxide. This is considered to be a anhydrous base, because if I later on put this in water, metal oxides plus water always makes bases, and anhydrous means without water. So metal oxides are considered to be anhydrous bases. Now, this just takes from that problem. If I take that oxide, and an example would be calcium oxide, and I react it with water, it's going to make a metal hydroxide, which is a base. And your base would be calcium hydroxide. Calcium's a +2, hydroxide's a -1, so it's always in a 1:2 ratio. So you're making CaOH, and then you need the parenthesis around your hydroxide with a 2. And that is already balanced. There's 1 calcium, 1 calcium. There's 2 oxygens in here, 1, 2, and 2 H's, so that's balanced. And that concludes 44. So if you go over this and can do well on it, you should score well on the test. We're going to be having it on Tuesday. Thank you.